we'll be looking at preparation of carboxylic acids. How can we prepare carboxylic acids or arachidonic acid? How can we synthesize them? Synthesis. How can we synthesize them? Okay, so I can use the word preparation. I can also use the word synthesis. Okay, so since I'm using synthesis, let me just write synthesis here. So synthesis of carboxylic acids. Now remember, we have talked about this before when we're looking at alcohols. Remember, when you oxidize alcohols, primary alcohols to be specific, if you oxidize it, you are going to get a carboxylic acid, complete oxidation, sort of, okay? So you're using your oxidizing agent like your sodium heptaose dichromate 6 and your Jones reagent, okay? Those reagents will oxidize the primary alcohol to a carboxylic acid. Also, you can also oxidize aldehyde. For example, if you oxidize the primary alcohol to the aldehyde level using PCC, that's pyridinium chlorochromate, oxidize this from primary alcohol to aldehyde. You can further oxidize that aldehyde again using any strong oxidizing agent to get the carboxylic acid. So the complete oxidation of primary alcohols and aldehyde gives you a carboxylic acid. So we have done it when we're looking at reactions of alcohol. So example of such reaction, okay? Let me demarcate the board. Example, let's look at the first method, that is oxidation of 1 degree alcohol and aldehyde. Oxidation of 1 degree alcohol and aldehyde. So if you undergo this oxidation, for example, if I have an alcohol, this is a primary alcohol, okay? This is a primary alcohol. A primary alcohol undergoes a complete oxidation to give us a carboxylic acid. An aldehyde functional group undergoes oxidation also to give us a carboxylic acid. So the reagent, of course, you know the reagent for oxidation, so I'm not going to talk about that one. You already know the reagent for oxidation, okay? So that is a method of what? Producing a carboxylic acid. Number 2 is carboxylation of alkyl halide, okay? Carboxylation of alkyl halide. So remember, we have carboxylation of alkyl halide. Now remember that we have alkyl halide. If you have an alkyl halide X and you react it with magnesium to get in ether to get your Grignard. This is your Grignard, okay? You can further react it with what? CO2 to get something like this. And then you can further protonate this, react with an acid to have RCOOH plus MgX2. So this is the carboxylation process. So the reaction starts from here. The alkyl halide reacts with magnesium to form the Grignard reagent. The Grignard reagent undergoes carboxylation reaction with carbon 4 oxide here to give us this group. Then this group will further react with an acid to give us the arachidonic acid or the carboxylic acid. And then this is this byproduct, which is not important here. So an example of such reaction, I can have something like if I start with CH3Br and I treat this guy with magnesium in ether, we have a Grignard CH3MgBr. Then you further treat it towards CO2 to have CH3CO2MgBr, which you further react with an acid to have CH3COOH. CO2 means COO, okay, plus magnesium bromide. So you have something like this. This is an example of what I'm trying to say. So we can synthesize ethanolic acid from this process. So today we'll be looking at synthesis of acid halides or acid chlorides, okay? So the number one way we can synthesize an acid chloride is by heating phosphorus pentachloride and phosphorus trichloride with carboxylic acids. Okay, so what this means is that if you heat a mixture of carboxylic acids and the phosphorus pentachloride or phosphorus trichloride, you are going to get an acid chloride. Okay, so example, look at how the equation works. If you have RCOOH plus PCl5, so this plus heat gives you RCOCl plus POCl3 plus HCl. Okay, this is general formula. If you are using phosphorus trichloride, you have RCOOH plus PCl3. Okay, this will give you RCOCl plus H3PO4. Okay, so let's check if the equation is balanced. To balance this particular equation, I'm going to put 3 here to balance this one. So I also put 3 here to balance this. Okay, I think this one is already balanced without touching it. So this one has 3 hydrogens, so I have 3 already here. So the rest, I think it is okay. Now I'll put 1 here. It's balanced like this. So now this is general equation. This is the general equation on this reaction. So no matter the alkanoic acid, you can go ahead and carry out the reaction. For example, if you have ethanoic acid and you are treating it with phosphorus pentachloride, you have CH3COCl plus POCl3 plus HCl. Okay, so the product of this reaction, the acid halide or the acid chloride. Remember, when we say acid halide, we are talking about acid chlorides. Okay, acid chlorides mainly. We're talking about this. So the acid chloride we are going to get here is ethanoyl chloride. This is called ethanoyl chloride. Now let me give you one to do by yourself. Let's say you are giving this CH3 CH2 CH2 COOH plus phosphorus pentachloride. So what should be the product of this reaction? That is plus heat. Okay, heat also. So this will give you CH3 CH2 CH2. Remember, nothing happens to this side. What happens here is just the OH leaves. Okay, then chlorine replaces. So I'm going to have COCl. Then the OH and whatever that is left here will form these 2 compounds here. We'll recover it back. So plus POCl3 plus HCl. So what should be the name of this? If this one is ethanoyl chloride, what should this one be? 4 carbon. 1, 2, 3, 4. So this one should be what? Butanoyl chloride. This one should be butanoyl chloride. Okay, so this is a method we can use. So remember, if you also use phosphorus trichloride, this you can also get the ethanoyl chloride. Just that you balance the equation and get this. For example, you can do CH3 CH2 COOH plus PCl3. So this one will give us CH3 CH2 COCl plus H3PO4. So balancing the equation, I will just put 3 here, then I'll put 3 here. I think that's all you can do to balance it. So you will still end up having this. And this one is called propanoyl chloride. Okay, 3 carbon. 1, 2, 3. Propanoyl chloride. So that is how to synthesize acid chloride from this heating with PCl5 and PCl3.